I like to tell that I'm an engineer before I'm a scientist. I really am a strong believer that when you bring an engineer to scientific problems, you come up with new approaches to a problem. And you can approach problems with a different perspective that sometimes can actually solve the problem. My name is Nicolas Pégard. I'm an associate professor in the Department of Applied Physical Sciences. I'm affiliated with the Biomedical Engineering Department, and I also am a member of the Neuroscience Center. I started my lab with the idea that I could bring my perspective as an engineer to neuroscience research, because I'm very excited about developing custom technology and solving problems that others have. The lab we run is very much inspired by the legacy of Dr. Beckman. In 1934, when Dr. Beckman developed a pH meter, he did so because he was trying to solve a problem for one of his friends who was in the lemon production industry and needed a solution to measure the acidity of lemons. He developed a technology that was tailored for the purpose of answering a question that had been brought to him by others, and in the process discovered something that eventually now becomes a staple of every chemistry lab. We have a similar approach to scientific discovery. We're not a traditional lab that is driven by answering a scientific question that we created for ourselves. We're a lab that likes to go to talk to others and try to understand what is getting in the way of their dream experiments. And we come back to the design table and say, can we use all the building blocks that are available to us today and assemble them and program them into a technology that will answer that type of question and enable discovery in neurosciences. When I received the Beckman Young Investigator Award in 2021, all of a sudden I had the ability to start exploring directions with a much greater level of comfort. I could try new things and take way more risks that I would otherwise be comfortable with. One of the latest projects that we've been working on, a project that was funded by the Young Investigator Award, uses this concept of microscopy, so this camera that captures fluorescence image. But instead of taking a picture on the camera, we use a mechanical mirror to smear the picture on the camera. So each neuron is now a little line, and that line is mechanically controlled. So then when we analyze the image that is recorded by the sensor, we can actually recompose a time trace of the neuron while it was acquired on each frame. And so we basically change how the system operates to get more information. One of the recent success we had in the lab is in a collaborative project with the lab of Dr. Rodriguez-Omeguera in the Neuroscience Center. We realized that there was a technology we could develop together to track arousal in mice. So basically to track pupil size and eye motions and pupil dynamics. And all this information are biomarkers that are very important in the study of neuropsychiatric disorders, because discrepancies of the attention level are indicators that you may be experiencing symptoms of anxiety or depression or PTSD, for instance. With this device in place, we're able to let the mouse move freely in the environment that it's in, and at the same time collect their pupil size and other biometrics like heart and breathing rate. Right now, we have a technology that works in mice that can be used for studies of those disorders in animal models. But because we are close to the med school, we actually have collaborators who saw that and realized that, we can start exploring using the same technology in humans. And so right now, our team is developing a pair of glasses that integrates the same technology that we hope to test in humans very soon. That's going to be able to monitor pupil reactions in real time, continuously. That's going to help mental health professionals identify whether or not you are experiencing symptoms of wide range of neuropsychiatric diseases. The support of the Beckman Foundation did for me is, it's a prestigious award. So it really helped me gain visibility at UNC, at conferences, and it helped me attract talented students because they want to work with me. I was very humbled by that. All of a sudden, you're a group that is doing research that a very well-recognized institution has deemed is worthy and is exciting. We hope to make life better for people. And in the process, we want to make discovery and solve problems that are outstanding. That's the driving force.